Okay, let me give an example. So x follows the binomial distribution with the number of successes equal to 2. Success probability is the theta, and then we want to test that h0 is theta equal to 1/2 versus h1 is theta is equal to 3/4. So these are simple hypotheses, and we will have to find UMP test. So based on the theorem, or sorry, based on the lemma, so we reject if the ratio under the alternative and null is greater than k. So this is the first condition that we have discussed. So we need to find this ratio, and by choosing different k, so we can have a different rejection region. So if you calculate this one, so when x equal to 0, this ratio is 1/4. When x equal to 1, the ratio is 3/4, and x equal to 2, the ratio is 9/4. So because we have 3 different values, then we can have 4 different tests for the tests. I mean for the UMP tests. So test 1 is if we choose k is less than 1/4, we always reject H0 because remember that we have we reject if this ratio under the alternative and null divided by under null is greater than k, then we reject the null hypothesis. Then we have different, so we have the criteria is 1/4. We have 3 cut points: 1/4, 3/4, and 9/4. Then, since the 1/4 is the smallest value from the among the cut points, so if k is less than 1/4, we always reject H0 because the x only can take 0, 1, and 2. And for test 2, we choose KB between 1/4 and 3/4. Then we reject H0. We reject H0, x is equal to 1 or x is equal to 2. So here, x equal to 0, the ratio is 1/4. So if k is greater than 1/4, then definitely when x equals 0, we do not reject. But still, we reject the H0 when x equals to 1 or 2, because when x equals to 1, the ratio is 3/4. X equal to 2, ratio is 9/4. And then test 3. When k is greater than 3/4 and less than 9/4, we reject H0 if x is equal to 2. So again, if x is equal to 0 or 1, that's less than 3/4 when k is between 3/4 and 9/4. So the only case when we reject null is x equal to 2. And test 4. In case it's greater than 9/4, we always not reject H0. So let all four tests be UMP level alpha 1, alpha 2, alpha 3, alpha 4 respectively. So we know that they are the UMP test. But now we want to find UMP level alpha test. So we will have to find levels. So test 1 theta 1 theta is, since this is probability reject H0. No, since we always reject, so this probability is 1. So for the first test, alpha 1 is equal to 1. And then test 2, 2 theta. So this is power theta equal to 1/2. X is equal to 1 or 2. Because we only reject x is equal to 1 or 2, and then the level is we only consider the probability under the null. So null is theta is 1/2, so which is 2 plus 1/4. This is 3/4. So alpha 2 is 3/4. And test 3 is only x equal to 2, so which is 1/4. Alpha 3 is equal to 1/4. And test 4 is, so alpha 4, test 4, since we always not reject, alpha 4 is equal to 0. So we can find levels for UMP test. And then we have a simpler way to find UMP level alpha test by using sufficient statistic. So corollary, so it's So we have simple hypotheses, and we have sufficient statistic Tx for theta, and Gt given theta I is the PDF for PMF of T corresponding to theta I, where theta I is 0 or 1. And any test based on sufficient statistic with precision region S is a UMP level alpha test if it satisfies So if we have first the condition that if the ratio under the norm, under the alternative based on PMF of the sufficient statistic is greater than K, then the sufficient statistic belongs to the rejection region. And if the ratio under the norm and alternative based on PDF or PMF of sufficient statistic is less than K, then the sufficient statistic belongs to the acceptance region for K is greater or equal to 0. This is the first condition. The second condition is the alpha is the probability that T belongs to the rejection region. So if we have these two conditions, then we have the UMP level alpha test. So here everything is the same as the Neyman-Pearce lemma, but we replace the PDF for PMF under sufficient statistic, and then rejection region is expressed by the sufficient statistic. So if we can find sufficient statistics, then we can find the UMP level alpha test by using information of sufficient statistic. Information of sufficient statistic. Let me give one example. we have a normal random sample with mean theta and variance sigma square, and we assume that sigma square is known. And we consider testing under the null theta is equal to theta 0, under the alternative theta is equal to theta 1, where theta 1 is greater than theta 0. And we would like to find the UMP level alpha test. And we know that the sample mean is the sufficient statistic for theta. So by corollary above, we reject if the PDF based on sufficient statistic under the under the alternative is greater than k times PDF of sufficient statistic under the null hypothesis. And we can easily find the PDF under the sample mean. So So we reject if so this the left hand side is a g t given theta 1, and the right hand side is the k times g t given theta 0. So if we calculate difference of two squares, then we can get 2t times theta minus theta 0 minus theta 1 square minus theta 0 square. And then by taking log function in both sides, and then by multiplying 2 sigma square divided by n in both sides, then and then I express it as a k star star, which is modified from k star, where the k star is the in this case is the log of k. So if we multiply one more again, we can get t is greater than k star star star. Here the theta 1 and theta 0, they are constants, so we can in this case add theta 1 square and minus theta 0 square on k star star and divide by theta 1 minus theta 0, and then I express it the new form of k star star as the k star star star. So UMP test, or if I say the level alpha test, although we haven't figured out for k to be on size alpha test, so level alpha test is reject H0 if the sample mean greater than k star 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 Now we need to figure out which k gives us the size alpha test. So we would like to find probability, we would like to find the k star star such that probability x bar is greater than k star star is the alpha. Then when we do standardization, then we have this result. And under the law, this ratio, the left hand side, the ratio in the left hand side is the standard normal. So this is equal to the z alpha. So k star 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 is equal to theta 0 plus z alpha times sigma divided by square root of n. We reject h0 if x bar greater than theta 0 plus z alpha times sigma divided by square root of n, which is the usual one-side z test.